Welcome to this introductory course on hazard and operability studies. The course will take you through an introduction, familiarize you with the methodology, the team composition, besides looking at the advantages and limitations of this technique. Let's get started with some key definitions. What is hazard? How is it defined? It is a characteristic of the system, plant or process that represents a potential for an accident causing damage to people, property or the environment. Cords posing a risk of tripping or water on the floor posing a slipping risk are good examples. What about an accident? How would you define an accident? A specified unplanned event or sequence of events that has undesirable consequences is defined as an accident. When the trips or fall happen causing injury, that becomes an accident. Or another example could be an equipment failure causing fire or damage to property. Look at this picture. Can you identify the hazards? I am sure you have spotted many hazards, like the inherent hazards due to flammable materials, possibility of a spill hazard, hazards associated with work at height, torn wires, the ergonomics, etc. Why are organizations a lot more conscious about safety and risk identification and mitigation techniques? Two of the worst industrial disasters in fairly recent times, like the Bhopal gas tragedy in India in 1984 and the Pasadena incident in Texas in 1989, caused many landmark changes. Let's look at the Bhopal gas tragedy closer to see how a period process hazard analysis could have prevented the death of over 20,000 people. We will revisit the Pasadena incident again at the end of this course. Many of you are already familiar with this case by now. As you perhaps know, on 3rd December 1984, there was a leak of methyl isocyanate from a storage tank in the Union Carbide plant at Bhopal, India. The vapor spread beyond the plant boundaries to a shanty town which had grown up around the plant. Over 2,000 people were killed within hours. According to the official reports, the material in the storage tank had become contaminated with water and chloroform, causing a runaway reaction. The precise route of the contamination is not known. A HAZOP study might have shown up possible ways in which contamination could have occurred and would have drawn attention to the need to keep all supplies of water well away from methyl isocyanate, with which it reacts violently. PHA techniques. Various process hazard techniques are available to us today, like checklists, safety audits, hazard identification or hazard, what-if analysis, failure mode and effects analysis FMEA, hazard and operability study HAZOP, preliminary hazard analysis PHA. PHA must primarily address the hazards of the process, consequences of identified hazards if there are nil or inadequate safeguards, and the engineering and administrative controls applicable to the hazards and their interrelationships. The table here shows you against each technique the best possible stage for its adoption or use. Of all the PHA techniques, HAZOP is widely used in process industries, both in continuous and batch processes for hazard analysis.